Okay, today I'm going to talk about quadratic transformations. If you remember back to our absolute value transformations, this is like the same thing. So the first thing that we need is the parent function, which means the most basic version of a quadratic function. So the parent function is going to be f of x equals x squared. Quadratic means that this has a power of 2, and that's your highest exponent. So the most basic one is when there's nothing else there. So this is the parent function. So whenever I'm talking about a transformation, I'm talking about in relation to the parent function, what changed. So we have a couple of things. The first thing we're going to look for is our vertex. If you graph this out, the vertex is going to be at 0, 0, and it's just going to be a U-shaped parabola like this. So this is what you're looking at. There's a lot of changes that can happen to this. The most important, or the first primary one that we're going to look at is the vertex. The vertex is where it changes directions. So it's going down, it stops, and now it's going back up. So we're going to look for the vertex. In order to find that, we want it to be in this form right here, which is very similar to the absolute value one. So your vertex is at HK. Now notice that this says minus, so whatever the sign is here, the sign is the opposite here. It's really important that you do that. So vertex is HK. On this one there's no H, so H is 0. There's no K, so K is 0. So if I give you a function rule like this, and I ask you for the vertex is going to be 2, 9. So what that means is, from the parent function that looks like this, the only change in this graph is it moved 2 units over to the right and 9 units up. It's the same shape, it just moved over. So I would say that the transformation is right 2, up 9. And that's stuff that we've already done. So it should be pretty simple. The next part, we're going to say vertical stretch and compression, which if you remember is our A value. So what's going to happen here is we're going to take this function rule that we just made and we're going to put A in there as well. So A is on the outside of the parentheses. A is your stretch or compression vertically. Now if the absolute value of A is greater than 1, it's a vertical stretch. If the absolute value of A is less than 1, it's a vertical compression. Now, that's not the only thing that we have to look at. We also have to look at the sign, because the sign of A can reflect us across the x-axis, which that's going to happen if A is negative. So if A is a negative, it's reflected across the x-axis. So if I give you the function rule that looks like this, a couple of things are happening here. The first thing that's happening is that it's moving to the right 4, up 9 from this and this. The 3 is vertically stretching it by a factor of 3. And the negative is reflecting it across the x-axis. So there's a lot of stuff that's happening there. Now that's not the only thing that we have. We also have horizontal stretch and compression, which is going to come from our B value. So I'm going to modify this equation. Now notice that the B is on the outside of the parentheses. So just because you, notice that the B is on the outside of the parentheses. So just because you have a number in front of your X does not make that number your B value. Sometimes you have to factor it out. But let's look at it. Let's say that we have an example that looks like this. So we got a lot of stuff happening here, obviously. The first thing that's going to happen is this 4 is going to move it left 4. This 9 is going to move it down 9. This 3 is going to vertically stretch it by a factor of 3. Because it's negative, it's going to reflect it across the x-axis. This 7 means that my b value is 7, which is going to be a horizontal stretch by a factor of 7. So when the absolute value of b is greater than 1, it's a horizontal stretch. When the absolute value of b is less than 1, it's a horizontal compression. And remember that it's 1 over b when you're looking at this, so that's really important. And then if b is negative, that's going to be reflected across the y-axis. So there's a lot of stuff coming in here, and there's a lot of stuff that we need to use. Okay, I'll do a couple more examples. The more difficult ones are when it looks like this. It looks like I have a b value, but that's not my b yet because it's not factored out. So what I need to do is I actually need to factor this out. It's going to be 4 times x plus 2. I divided this by 4 and this by 4. I put that squared in the wrong spot. I apologize. There we go. So now I know what my b value is, and I know what my h value is. If you don't factor it out, you're going to get the wrong h value. So I'm gonna say that my h value is -2, which means I'm moving to the left 2. The k is -4, so I'm going down 4. This 4 is on the outside, which means the b is really 1 over b equals 4, which gives me b equals 1/4. So that means that it's smaller than 1. So it's going to be a horizontal compression by a factor of 4. And that's what you're looking at. I think you just need to get a bunch of practice of this and it'll be pretty simple.